So we're verifying identities today in this assignment, and I want to run through the solutions. It'll be good for you to have your identities list handy while you're working on these problems. So let me bring that into the video right now. So we've got these notes handy now, and our job, remember, is to make this thing look like this. So we're going to try and turn 1 over tangent squared of x plus 1 into cosine squared of x. And this tangent squared of x plus 1, that actually is addressed right here in one of our Pythagorean identities. So instead of writing this as 1 over tangent squared of x plus 1, I'm going to rewrite it as 1 over secant squared of x. And that's true because our identity tells us that 1 plus tangent squared of theta equals secant squared of theta. And it's okay if these are commuted, right? Addition's commutative, so they're both equal. And so now I have this 1 over secant squared of x. That's one of our reciprocal identities. Take a look at this guy right here. Cosine of theta is 1 over secant squared of theta, or secant of theta. So I can rewrite this as just cosine squared of x. And I made it to the expression that I was shooting for. I used a Pythagorean identity and a reciprocal identity to make it there. And that's all you do for these problems. Let's take a look at number 2 on the next slide. So here's problem 2, and again, let me bring in my identities. Our job is to turn this side into this. And I'm actually going to take advantage of this little alternate form for the reciprocal identities here. If I take this right-hand side, the secant of x over secant of x, plus or minus 1, and I multiply the top and bottom by cosine of x. And that's okay. That's called multiplying by a form of 1. I'm not changing anything. I'm just multiplying by 1. But what that does is that gives me that reciprocal relationship there, and this numerator just turns into 1. And then when I distribute this, remember there's implied parentheses here, so I'm going to distribute the cosine of x down here. The cosine of x times the secant of x is also a 1, and then 1 times cosine of x is cosine of x. And lo and behold, I made it. I got what I was shooting for, which is this 1 over 1 minus cosine of x. So in this case, our strategy was simply to use this alternate form of the reciprocal identity, multiplied by a form of 1, which is a little trick we use a lot in math to transform expressions. I multiplied by cosine x over cosine x, and that gave me the 1 in the numerator, and that gave me the 1 minus cosine of x in the denominator. I like that problem. Okay, let's go on to number 3. Here's number 3, negative cosine of x times tangent of x equals negative sine of x. And in this case, I'm going to use a reciprocal quotient relationship right here. Tangent of theta equals sine of theta over cosine theta. So I'm going to transform this tangent into sine of x over cosine of x. And when I do that, I've still got this negative cosine of x right here. But these guys are going to cancel, right? We know that when you have an expression in the numerator and an expression in the denominator, you can cancel these out. And so I end up with exactly what I was shooting for, which is negative sine of x. So that one, I just use one identity to get to the goal, which was this negative sine of x over here. Pretty straightforward on that one. I just use that quotient relationship, sine of x over cosine of x. I like that problem. All right, let's continue on to number 4. In number 4, I've got 1 over tangent x times secant squared of x, and I'm trying to turn it into this. So I think the best thing for us to do here is look at our reciprocal relationships. 1 over tangent is going to be the same as a cotangent, which is right here. And 1 over secant is the same as cosine, which is right here. So I'm going to split this fraction into two pieces. It's really 1 over tangent of x times 1 over secant squared of x. And we know 1 over tangent of x is just cotangent of x from our chart. And we know 1 over secant squared of x is just cosine squared of x. And then I can just use the commutative property from algebra class to change the order of these things, because multiplication is commutative, and I end up with exactly what I was shooting for, which is the cosine squared of x times the cotangent of x. So we use two little reciprocal identities, and we transform the left side into the right side. Starting to see a pattern with these things, I hope. Let's crank it out and let's keep going. On number 5, we're going to use a similar strategy that we used in the last slide. I'll consider these reciprocals. 1 over secant is just cosine of x, and 1 over cotangent squared is just tangent squared. And so then I can commute these like I did before, and we get exactly what we were looking for, which is tangent squared of cosine of, or times, not of, tangent squared of x times cosine of x. When they write them next to each other like this, it's implied that there's a multiplication there. The other thing I should note is sometimes you'll see these trig expressions written without the parentheses. So if you see something like tangent squared x or cosine x, those mean tangent squared of x and cosine of x. Okay, so I made it to the expression we wanted. I don't want to make this video go too long, so let's just go on to number 6. In number 6, I think I'm going to have to use the reciprocal relationships again. I can write sine of x as 1 over cosecant x, which is right here. And I can write cotangent squared of x as 1 over tangent squared of x, and that is right here. So I'm going to make a complex fraction. I'm going to turn the numerator into 1 over tangent squared of x instead of cotangent of x. Right, I took this guy and did it here. And then the denominator, I'll make it 1 over cosecant of x. That's this one. Now, this is a complex fraction. Remember, the way we handle this is we write down the numerator, and then we flip the denominator, which is this guy here, and we multiply instead of dividing. So this is, oops, spelled that wrong, cosecant of x over 1. And now when you multiply these together, you get exactly what we're shooting for, which is cosecant of x over tangent squared of x. So we made it. That's exactly what we were asked to find. And we just use these reciprocal relationships as well as our strategy for simplifying a complex fraction by flipping and multiplying the denominator. That's number 6. Let's move on to number 7. I'm actually going to use a similar strategy on number 7. Remember that secant of theta is just 1 over cosine. And remember that sine of x is just 1 over cosecant. So we'll rewrite, we're working on the left side here, we're going to rewrite the secant squared of x as 1 over cosine squared of x. And we'll rewrite the sine of x as 1 over cosecant of x. And then this one plays out very similar to the last problem. We're going to flip and multiply. And then, yes, it works out. We get cosecant of x over cosine squared of x. So nothing fancy on these last two problems. They're very similar. We're just using our reciprocal identities and then remembering that we can simplify a complex fraction by flipping the denominator and multiplying. All right, one more problem and then we're done with this thing. So I'm asked to turn cotangent squared of x times minus tangent squared of x into cosecant squared x minus secant of x. For this one, I think we're going to have to use some Pythagorean identities. In particular, I'm going to use the 1 plus cotangent squared of theta equals cosecant squared theta, and the 1 plus tangent squared of theta equals secant squared of theta. I'm going to have to write them in a different form, though. This first one, instead of writing 1 plus cotangent squared of theta equals cosecant squared theta, I'm going to subtract 1 for both sides. So I'm rewriting that identity so that it looks like this. Oops, I forgot the of x. So this is the same identity as this guy right here, except that I've subtracted 1 from both sides. So I'm going to use this form because I want to stick that right here where the cotangent squared is. I'm going to use the same trick for the tangent. Instead of 1 plus tangent squared, I'm going to subtract 1 from both sides, and I'll get tangent squared x equals secant squared of x minus 1. So again, I just changed this guy, and what I want to do is put this right here. So let's write all this out and see what we end up with. Instead of cotangent squared x, I'm going to write cosecant squared of x minus 1. Then there's a minus sign right there. And then I'm going to put secant squared of x minus 1. It's in parentheses because this minus sign applies to both of these guys. So be careful with that. So when I do that, I get cosecant squared of x minus 1. I'm distributing the minus. I get minus secant squared of x plus 1. And then, ooh, this is good news because look, I've got a minus 1 right here and a plus 1 right here. Those make 0. And I made it to the goal, which was I have cosecant squared of x minus secant squared of x. And we are done. That is what we were trying to achieve. Yay! And so that is my last identity for this assignment. Hopefully you did well without the video, but if you needed it, hopefully the video helps you understand the solutions to these 8 problems. If you need me, you know how to get a hold of me. In the meantime, take care.